Okay, so let's discuss this another interesting problem, that is house robber, right? So in this problem, we have been given that we are planning to rob houses, right? And we are supposed to rob the houses in such a way that we don't rob we don't rob adjacent houses. Like if I rob at this house at index 0, then I can not rob at house 1, that is immediate to the house at index 0. Let's say if I plan to rob at house number 2, that is index number 2, then I cannot rob at this index. So this is what is being asked, right? And we want to rob in such a way that we make the maximum profit. So this is an optimization problem, right? Like we want to maximize the amount that we rob. So for example, let's say if I rob at index 0, I can then rob at index 2, or if I don't rob at index 2, I can rob at index 1, or I can also skip this index. So what are the cases? Let's say if I'm standing at index 0, what are the two possibilities? Either I rob or I don't rob. According to that, what I will do, I will make further recursive calls. Why is it a recursive problem? Because let's say if I have been given array like this, like let's say we don't have this 1 over here, we have 2 3 1. If I have solution for this problem, can I not find the solution for this one and then you know maximize the profit? Let's say if I have the maximum output over here, the maximum amount of money that I can rob out of this place is, let's say, 4. Then what I can do is I can either add this one or I can remove this one, right? And maybe then we can get the optimal answer, right? So now that we are clear with our intuition, like why is this optimization problem, why are we solving this recursively? Because we are trying to repeat things over and over again for every index, right? And so I think we are clear with the intuition. Let's just code it up, right? So now let's say we call helper function, and what are we going to pass to this helper function? We are going to pass the index that we are going to start at the index 0, and we are going to pass nums, right? The array. Okay, so our function is going to return an integer. Currently we are at the index and the array is nums. We are passing it by reference, so there is no extra memory being required. Now what are the base cases? Let's say if the index exceeds the nums size, index becomes greater than equal to nums dot size. That means we don't have anything to rob. Now that we don't have anything to rob, what will be the maximum that I can rob? I can rob a maximum amount of 0, right? So I just return 0. Now two possibilities, either I rob or I don't rob, right? So let's say we find out for rob. Rob means we have to add the current index. We are robbing the current index. So we will say add nums of index to our answer and make further recursive calls for further indexes. Now what should I do? Should I go for index plus 1 or index plus 2? We will go for index plus 2. Why index plus 2? Because if I'm robbing at the current index, I cannot rob at the immediate index that is next to the current index. So I'll say index plus 2, and I'll pass on nums. Now int do not rob. So what do we add? Let's say we are not robbing at the current index, we add 0. This is just for understanding, you don't need to add 0 over here. And then we can try our luck at the next index, whether we want to rob or we don't want to rob. And what do we return? We return maximum of op and do not rob, as simple as that. Okay, now let's try running this code. All right, so test cases have been passed. Now we'll definitely get a TLE. Why we are going to get a TLE? Because as you can see, we are playing the game with exponential complexity. How come exponential? Because at each index that we are visiting, we are making two recursive calls. So we have two possibilities. So at each level, if we have two possibilities, and at each level they will again make two possibilities, right? So it will lead to exponential recursive calls. Let's say at first level I have this helper function. This will call these two helper functions. These two will in turn call four helper functions. All in all, those four will again call eight helper functions. So this is how it is increasing, right? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. The level wise the number of recursive calls is increasing. So we have to optimize our solution, right? Because 2 raised to the power 100 leads to exponential complexity, and that won't be accepted, right? So let's optimize. So let's first write the memoization solution, and then we can proceed with the tabulation solution. Okay, so let's initialize a vector of int dp. What will be the size of the dp array? It will be 1 greater than the size of nums. Okay, we can take 1 greater, 2 greater, doesn't matter. Okay, but we should try taking at least one extra, and that reason you guys should let me know why are we taking this one extra. So now we initialize it with -1. We pass the dp array. We go over here, we say vector of int dp. Let's say if we have the answer for current index. Okay, let's say we have the maximum amount of money that I can make at current index. We already have it, right? After on from current index. So what we will say, if dp of index is not equal to -1, you return dp of index return. Okay, now pass on this dp array to these two function calls, dp, and we'll also store the answer of dp, the answer for the current index in the dp array, right? And this should work. Okay, so let's run this code. Let's try and submit this. Okay, so we have submitted, right? Now let's look on to optimize it. Okay, so now let's write a space optimized solution. Int solve tabulation. Okay, we will pass nums over here. Okay, now how to write tabulation. Okay, so let's see, return solve tab nums. Okay, so now what is the step 1 to write tabulation? Step 1, create dp array. So what I'll do, I'll just create a dp array, vector int dp of nums dot size +1, and I'll initialize each and every cell with 0. Okay, now what is dp of index representing? Dp of index is representing the state. Okay, it will represent a state, the state that will state that beyond this index, beyond the current index, what will be the maximum profit or the maximum amount of money that I am able to make. That is dp of index. Are we clear on that? Okay, so dp of index represents the maximum amount of money that I can make starting from this index. Okay, so now currently we are initializing it with 0. Okay, so now what is step 2? Step 2, copy down the base cases. Okay, now what are the base cases? The base case is this one, right? Now let's say if the index exceeds nums dot size, or it is equal to nums dot size, we are returning 0. We don't need to handle this case separately over here. Why? It is because we have already initialized our dp array to 0, so not required. Okay, but we generally do it, not in this case. Now what is the next step? Next step is to check the variables in the recursive calls. What is changing? Index is changing, right? Only index is changing, and index is going from 0, like over here it was going from 0 to nums dot size minus 1, definitely, because we are making recursive call for nums dot size minus 1, because as soon as it becomes greater than or equal to nums dot index, we are returning 0 eventually, right? So now let's say we were over here we were going from bottom to up, right? So from here we will try on to go from top to bottom. So I'll say for int index equals nums dot size minus 1. Okay, why are we taking nums dot size minus 1? Because as we can see in the base case, if index becomes equals to the nums dot size or greater than equals to nums dot size, we don't have to perform any computation, we are immediately returning 0. Whereas if it is nums dot size minus 1 or less than that, we are going to do computations. Okay, this is what we are going to compute. So now what do? We make the loop go up till 0, because we are going from nums dot size minus 1 to 0 and index minus minus. Now what will be the next step? The next step is very easy. How come it is easy? We are going to copy this logic and we are going to paste it over here. Okay, we are simply going to paste it. Okay, now what are we supposed to return? The same thing that we were returning, right? Since we are coming from top to bottom, our answer will format index number 0. How come index number 0? See, over here in the memoization code, we were returning answer for dp of index, and as you can see, the recursive calls were starting for index number 0. So our ultimate answer will be formed for index 0, right? So now we return dp of 0. Okay, now let me just change this to the dp calls, right? We have created a dp array over here, so we'll say dp of index plus 2, and what else we are going to, oh, it is 1ddp, right? So we don't have to pass anything else, and this will be the call for index plus 1. This will be the call for dp of index plus 1. Okay, now this is it. So let's run this code. Okay, so we have heap buffer overflow error, right? So why is it so? If it is nums dot size minus 1, I add 1, it becomes equals to nums dot size. Okay, oh, let me just make this to 2. Okay, let's run this code again. Okay, so now it works. So what was the reason? The reason was this call, right? dp of index plus 2. Okay, so now let's say if the array was of size 4. Okay, so what will be the nums dot size minus 1? That will correspond to the last index, that is 3. And over here we have initialized it for, initially it was num size plus 1, right? So we could accommodate the calls up till index 4 only, right? If the array was of size 4, we could find the answer for, if it was over here, it was in nums dot size plus 1, so we could only find the answer for index 4. But over here we are making call for index plus 2, that is 3 plus 2, that is 5. Okay, so there was no 5, so that's why we were getting heap buffer overflow error, right? So now we have handled it. Okay, that was a mistake on my part, and sorry for that. So yeah, this will submit eventually and we will get a better space complexity this time, maybe. Okay, not that much, not that good, right? Because ultimately we are using the same dp array, only the recursive stack calls have been reduced. So let's optimize it again, optimize it further. Let's optimize it further. Okay, how we can optimize it further? As you can see over here in this dp array, what are we doing? We are making recursive, we are not making recursive calls, right? We are basically calling states for a particular index. Let's say if I want to find out the answer for index, I am asking for the answer for index plus 2 and index plus 1. So instead, because at any point in time, at a current at a particular index, what I'm doing is I am asking for answer from index plus 2 and index plus 1, and rest all cells, they don't matter to me. So what I can do is, instead of initializing this dp array, what I can say is, for a particular index I'll make two variables. Okay, these variables will give me the answer. Okay, let's see. Int, let's call them next one. What will be next one? Next one will be a 0 initially, and the next two will be 0. Okay, so now let's understand like what's going on. Let's say we have 4 5 6 7 8 9. Okay, currently I'm at 9. So what do I want? I want the answers for indexes that are next, that is next to next. So these two indexes, let's say वैसे तो यहाँ पर नहीं है कुछ इंडेक्स, राइट? यहाँ पे कोई इंडेक्स नहीं है, सो ये एम्प्टी है ना, तो यहाँ पर इनिशियली वी हैव इनिशियलाइज्ड इट विद 0, लाइक नथिंग इज आफ्टर 9. सो इन ऑर्डर टू कंप्यूट द answer for 9, like from 9 what can be the maximum amount of money that I can get? Either I rob at 9 or I do not rob at 9. So let's say if I'm robbing at 9, I will make a call for this one, index plus 2, and this will return 0 eventually because this is 0, right? So the maximum will be 9, because if I don't rob at 9, what will be the what will be the answer? 0, definitely, because we are making call for this 0 right here. So I hope I am clear. So what I can do is, let's say this is next one, this is next two. Okay, so okay, let's just comment this one out. Okay, so now what I can do is I can replace it with the next two, and I can replace this with next one. Okay, I will have to make, since I have to store the answer, right, and I have to return the answer, I'll make a current variable as well. I'll initialize it with 0. Okay, why are we initializing it with current, my friend? Because if this is the current index, this is next one, this is next two, so current represents dp of index, next one represent dp of index plus 1, and next two represent dp of index plus 2. So here we have written next two, here we have written next one. Over here I'll write current. What I'll write current. Okay, now as you can see, what was the case initially? Initially the case was that that 9 was current. Okay, 9 was current, this was next one, and this was next two. Now we have calculated current. Okay, so we are going to shift backwards. Okay, we are going to shift backwards because our current will change. So now our current will change to 8, right? Not 8 exactly, it will shift one step back. Okay, as you can see, we are doing index minus minus, so this current that is going to shift to this place. So if I just wipe this off, current comes over here. Now as you can see that current has entered a new place, and n1 has shifted to the position of current, and n2, if you can see, has shifted to position of n1. Okay, what was the case initially? N2 was under this 0, n1 was over here, pardon, so n1 was here and current was not here, current was here actually. Okay, so now that they have shifted positions, we have to change the values, right? So now current will come here, that current's answer will be here, n1 will be the next to current, and n2 will be next to, right? N1 will be next one and n2 will be next to the current. So I hope I'm clear. Okay, even if I'm not, you can just repeat the video. I've taken this example to explain, right? So what I will do, I will make some changes. So now that I have computed current, I'll say next one should be equal to current, and next two should be equal to what? It should be, okay, let me just first update next two, sorry, because we are updating next one afterwards, right? Otherwise we'll lose next one's value. So I'll say it should be equal to next one. Okay, we are basically changing the values, we're shifting them. Okay, so this is it. Now what happens? Let's say after all the computations we have reached to this position that we are computing for index 0, this is next one, and pardon, this is next 2. Now eventually we will compute the result for current, and what will happen then and there, we will store current in next one, right? So what are we going to return in this case? We are going to return next one. So let's run this code, and it works fine. So let me just, yeah, so we have that. So I hope I'm clear. Like, this is current, right, for index 0. Next one will be the answer for this index, okay, and the next two will be the answer from this index. So we are ultimately calculating the maximum by adding or by not adding, as simple as that. Okay, so this is it. This is the brute, optimal, more optimal, and so on version of the house robber problem. Okay, so thank you all.